Welcome back, STEM students, to Mampaisan's online classroom. So today we're going again to have a new lecture video, and this time it's going to be about projectile motion. Okay, so we're already in Module 4, and Module 4 is all about two-dimensional motion. And the focus of two-dimensional motion lecture or discussion would be the projectile motion. Here are the objectives for this lesson. We have number 1, define and describe projectile motion. Number 2, deduce the consequences of the independence of vertical and horizontal components of projectile motion. Number 3, calculate range, time of flight, and maximum heights of projectiles. And number 4, solve problems involving two-dimensional motion. As an overview, we're going to have the following subtopics. Number 1, projectile motion, description and definition. Number 2, horizontal and vertical components of projectile motion. Number 3, projectile motion, case number 1. And lastly, projectile motion, case number 2. This lesson is divided into two parts. This is part 1. Let's first discuss projectile motion, description and definition, as well as the descriptions for the horizontal component and the vertical component of projectile. Again, sabihin ko ulit, this module 4 is about two-dimensional motion, which is motion that happens in a plane. Remember, in geometry, when it's one-dimensional, it's usually denoted as lines, o kaya naman rays, segments, mga ganong term. Pag sinabi natin two-dimensional na siya, it's already a plane, parang mga plane figures, ganyan. Okay? And particularly, this two-dimensional motion happens in the Cartesian plane. So, kaya may mga x and y components tayo, no? There are two major types of two-dimensional motion, the projectile motion and the uniform circular motion. However, we are just going to focus on projectile motion. Projectile motion is a combination of vertical and horizontal motions that are completely independent of each other. Meaning, again, si projectile motion kasi usually the path looks like this. Pag ganyan. Okay? And this path is, kada point niyan, merong specific vector. These vectors are composed of the position, are either the position, the velocity, or the acceleration. And each kinematic quantity associated with it, since at an angle nga siya, kung mapapansin nyo, it's composed of two components, the x and the y. Ito yung y component, tapos ito naman yung x component. So your displacement has x and y component, your velocity has x and y component, as well as your acceleration. Now we do computations, separating computations for vertical and horizontal. Okay, that's why we say that they are independent from each other. The horizontal component does not affect the vertical component, and vice versa. Now, another thing about projectile motion is that it's free fall, meaning we neglect the effect of air resistance and other forces, and we are just considering the effect of gravity to the object undergoing projectile motion. Right? That's the assumption. No? Now, usually we see projectile motion in different events, no, in our surroundings. But most of the time, we see them in sports, just like in football, in tennis, in basketball, and in soccer. Diba, in football, it's not always that the player kicks the ball or carries the ball so that it would follow a straight path. No, usually, ang ifo-follow na path niyan, pwedeng pa ganun, na straight, o kaya naman pa ganun. Okay, kasi after going up, it eventually goes down. The tennis ball is also following a path that is two-dimensional. Ganun. Kasi the tennis ball will not be able to go to the other side of the court above the net unless you project it at an angle. Basketball also, hindi mo pwedeng i-shoot mo, naka-straight lang siyang ganyan. No? Dapat pag ganun, para ma-shoot siya sa ring. The same as the soccer ball, it's not always that the players kick it in this way. Sometimes it looks like this. Okay, so things that follow such path undergo projectile motion. Now we have a special name for these balls, for the football, for the tennis ball, for the basketball, and the soccer ball. We call that as projectile, okay, because it's an object that undergoes projectile motion. Let's have an example here wherein a girl is going to shoot a ball towards the ring. So the ball will be considered as our projectile. So anything that undergoes projectile motion and follows a curved path is considered as a projectile. And then the curved path that the projectile follows as it undergo projectile motion is what we call the trajectory. Again, remember this trajectory or this path is composed of two types of motion, the vertical and the horizontal combined. So in each part of the trajectory, ganyan siya usually. Pwede rin pa ganyan. Depende sa case, no? Later we will see. Ayan. Kada point dyan corresponds to a certain vector at an angle, and again it's composed of x and y component always, no? And then ayan, if we're going to look at the ball, let's say na-shoot na niya yung ball. Ayan, shoot na niya yung ball pupunta sa ring, so the path is curved and we call that path as the trajectory. Next, the range, okay? So, kung masushoota niya yan halimbawa, dyan, mapupunta siya dito approximately or medyo mas mababa, no? Let's say, hindi ko natansya, okay lang yan, okay? No? The range would be this one, okay? The maximum horizontal displacement of a projectile. So, sometimes, in some books, it is written as X. In some books, it's delta X. Tapos, sa ibang book naman ay R. Pare-pareho lang ibig sabihin niya. So, if the ball reached the other side at same level, or if the projectile reached the other side of the path at same level, the horizontal displacement or the horizontal distance between the initial position and the final position would be what we call the maximum horizontal displacement or range. Pero kapag halimbawa, inanalyze mo lang is the horizontal displacement from the original position towards the highest position. So, ito lang yan. Ayan. Okay, tatapat mo lang horizontally. Okay? So, kapag ganyan, hindi na horizontal, hindi range ang tawag mo sa kanya unless ma-reach yung maximum. Tsaka mo lang siya tatawagin range. So, kapag ganyan lang, we simply call that as horizontal displacement. Hindi range. Okay? Those are the difference. Kapag ni-reach yung maximum, we call it range. Pag hindi, we simply call it horizontal displacement. Okay? Next term that you should know is the term height. Sometimes you see it as y in some books. In some books or in our convention, it's gonna be delta y. In some books, it's lowercase letter h. In some books, it's capital letter h. No, iba-iba. Now, the height is the vertical displacement of a projectile, and the maximum height is the maximum vertical displacement. So, kapag hindi niya, pag naka-maximum, ito, halimbawa, nandito yung bola mo sa pinakataas, you will be able to reach the maximum height. So, usually, we write the maximum height as h, and then max. Pero pwede na rin yung delta y. Okay? Pareho lang naman siya ng ibig sabihin, no? And then the vertical displacement, ito isulat natin. Ayan. The orange is the maximum height, while the green ones are the height, simple height. So kapag nandito naman yung bola mo, ayan, tapos gusto mong malaman yung height, hindi siya maximum height, of course. Okay? So kapag nakita mo sa problem yung height, that's the vertical displacement, delta y, pareho lang siya ng ibig sabihin pag sinabi sa problem na vertical displacement. They are synonymous to each other. Okay? Now let's proceed with the horizontal and vertical components of projectile motion. A projectile moves in two dimensions. Therefore, it has a component just like a resultant vector. Katulad nga ng sinasabi ko, dahil curved yung path niya, let's say sa position, that's displacement. Our displacement will have the delta x, which is the x component of the displacement, and then the delta y, try natin, erase. Ito naman yung delta y natin. That's the vertical component. And of course, kasi nga kapag motion, we use the kinematic quantities to describe them, no? So aside from the position, we also have the velocity. Now your velocity, since two-dimensional nga ito, would have the Vx and then the Vy. Ganun din sa acceleration mo, no? The A. The A will have the x component A sub x, or in this case, for projectile, we simply write it as A. And then for the y component, that's A sub y. Or since vertical motion ito, that's equivalent to G. Okay, later we will discuss more about that, no? Now let's describe the horizontal component. And again, air resistance is negligible or ignored here. First characteristic, velocity never changes or constant. Second, covers equal displacements in equal time periods. And lastly, gravity does not work horizontally to increase or decrease the velocity. Isa-isahin natin, ha? Let's have the velocity never changes or constant. Look at the diagram. At t is equal to 0, notice that the v sub x, or again, the velocity along the horizontal axis, or pwede rin natin tawagin. So, I'm trying to tell you the other terms, no? Para if you read it, you would comprehend. Kasi, di ba nga, vocabulary is very important in English and other subjects. Kasama yung, science, no? Kapag di mo alam yung iba't ibang term na ginagamit, pag nabasa mo sa ibang libro, hala, hindi naman to tinuro namin, hindi ganun, no? So, you should take into considerations the synonyms. So, the v sub x is the velocity along the horizontal axis, or pwede mo rin siyang tawagin as the horizontal velocity. Pwede mo rin siyang ganun tawagin. No? Notice that the horizontal velocity v sub x at t is equal to 0 is 8 meters per second. After 1 second, it is still 8 meters per second. Yan, tingnan mo lang yung mga red. And then, at 2 seconds, ganun pa rin siya. At 3 seconds, ganun pa rin. At 4 seconds, at 5 seconds, and at 6 seconds. Pare-pareho silang, 8 meters per second. So that's one characteristic of the horizontal component. Kahit ano pa siyang case, the horizontal component never changes. The horizontal component of the velocity pala never changes. Okay? Ayan. So, ibig sabihin at any point in time, the velocities are equal to each other. Next, covers equal displacements in equal time periods, meaning from 0 to 1 second, it covers 8 meters kasi ang speed niya ay 8 meters per second. Ibig sabihin yan, kada segundo nakakaabot siya ng 8 meters, no? So, dahil ganyan yung kanyang speed, magpatuloy-tuloy siya ng kanyang motion. Ayan. Puro 8 meters ang kanya natatravel. So, at equal time periods, our time period is 1 second. Kada 1 second, pare-pareho yung natatravel niya. Okay? Constant, consistent. Hindi nagbabago-bago. Okay? Next, let's have the gravity does not work horizontally. That the reason why the displacement is equal at equal time periods, and the reason why the velocities along the horizontal axis is equal all throughout the motion is because, again, for projectile, the only force that acts on the projectile is the gravity. And gravity is directed downward. So it only affects the vertical component of motion, not the horizontal. Kaya hindi nag-i-increase nor nagdi-decrease ang velocity at ang displacement or ang pagbabago ng displacement all throughout the horizontal component of motion. Sa vertical lang siya nakaka-affect. Okay, now here are the equations for horizontal component. Recall these equations are actually the same equations for HUAM or horizontal uniformly accelerated motion. This Vx is equal to V naught x should have the 80 here. May 80 yan siya dito pag binalikan nyo yung equations natin sa HUAM. Now, why did this disappear? Because this becomes 0. And the reason why is since there is no change in velocity and there is no change in velocity, meaning there is no change in the speed of the object kasi nga kanina di ba pare-pareho. And then as you will notice as well, lahat ng values niya ay positive, meaning the direction is constantly going towards the positive direction. No change in speed, there is no change in direction, meaning there is no acceleration, or in other words, acceleration is equal to 0. Kaya nag-0 tong part na to, which gives us V sub x is equal to V naught x. And then another one for equation number 3, ito, meron pa to dapat na 1/2 a t squared. Now again, since a is 0, ayan, we are left with this equation. And this equation can be rewritten as delta x is equal to V sub x times t. Pareho lang yan. Kasi remember, going back here, the V naught x is actually equal to Vx. Okay? And then, here for equation 4, especially in case number 2 of projectile, these two are useful because you will get the x and y components ay the x component of the final velocity, itong v nito, and the initial velocity. Later, we will define this. Ito, tingnan natin. Let's define each one. Let me emphasize that the Vx is different from the V. Okay? The Vx is the final horizontal velocity, meaning itong x na to, it denotes that the velocity is present in the x-axis. So the final velocity V, again, the velocities here have two components, the x and the y. So this one, the final horizontal velocity, is also synonymous to final velocity along the x-axis. So that's the x component of our final velocity. On the other hand, the v naught x, or the initial horizontal velocity, is the x component of the initial velocity. Okay? So, ibig sabihin ng horizontal dito, x component. Okay? And then the time, t, is time to reach the highest point or the lowest point, which depends on the case. Later, we will know. Okay? And then, the delta x is the horizontal displacement. Okay? Ayan sa mga equation. Okay? And then, the theta, of course, is the angle. Let's have the vertical component. Here are the characteristics. Velocity changes due to gravity. Does not cover equal displacements in equal time periods. And the velocity's magnitude and direction change. As the projectile moves up, the velocity's magnitude decreases and its direction is upward. As the projectile moves down, the velocity's magnitude increases and the direction is downward. Okay, sige, tingnan natin. Isa-isahin natin. Sa una, velocity changes due to gravity. Ito yung unang difference between the horizontal and the vertical. Because remember, in horizontal, the velocity does not change. Here, it changes. At t is equal to 0, it's 29.4 meters per second. After 1 second, naging 19.6. Ayan, tingnan nyo yung kulay blue na font na number. And then t at t is equal to 2 seconds, naging 9.8. And then at the highest point, time is equal to 3 seconds, ito siya. The velocity along the y is 0. And then After 1 second ulit, it became negative 9.8, tapos naging negative 19.6, and lastly, naging negative 29.4. So, nagbabago siya. And the reason is gravity. Because again, remember, gravity as a force is directed downwards, which means that also, although it is downwards, no, nakaka-apekto rin naman siya sa upward motion. Katulad nga ng sa free fall natin, di ba? Naaapektuhin niya rin yung pag-akyat ng isang object pataas. Therefore, gravity as a force only affect the vertical component of motion and not the horizontal. Okay? Next, it does not cover equal displacement in equal time period. So from 0 to 1 second, ayan ang kanyang vertical displacement. 1 to 2 seconds yan. And then 2 to 3. Tapos 3 to 4. Ayan. Tapos 4 to 5. And 5 to 6. Okay, ganyan yung ano niya. As you can see, the arrows are not equally spaced, or the arrows do not have equal lengths. So, pinakamahaba dito, tapos paiksi ng paiksi, tapos from the highest point, palaki ulit ng palaki yung kanyang displacement na nako-cover. Okay, and that's again because there is a change in velocity. Therefore, there will also be a change in displacement. Okay, next is the velocity's magnitude and direction change. Okay, pag pataas, tingnan mo, the value decreases. From 29.4, it became 19.6. From 19.6, it became 9.8. From 9.8, it became 0. Okay, but the sign is positive kasi nga, as our convention, everything that goes up is positive and everything that goes down is negative. That's why for here, ayan, as time goes by from the topmost part towards the bottom, you will see that the velocity's magnitude increases from 0 to 9.8, 9.8 to 19.6, and then 19.6 to 29.4. But the direction is downward. Ayan, negative na siya. Okay? Yan na siya kadali. For the equations, we have the following, which are the same as the equations for free fall. Ayan siya, no? And then, since again, anong tawag dito? Two-dimensional ito. So, the vector is at a certain angle. That's why we should consider the x and y component. So, this time, you're going to get the y component using the sine function. And here are the definitions. The v sub y is the final vertical velocity, meaning v sub y is the y component of v, or the final velocity. And then the v naught y is the initial vertical velocity, which means that it is the y component of our initial velocity. And then the time has the same definition because it is not dependent upon what kind of motion is happening. X and y man yan, pareho lang siya, no? Wala siyang kinikilalang direction kasi scalar siya, no? Kaya wala kang makikita t sub x o kaya t sub y, walang gano'n, okay? And then delta y is the height or vertical displacement, and the acceleration here is the acceleration due to gravity equal to negative 9.8 meters per second squared. So that's all for the part 1 of the discussion for projectile motion. Thank you for listening, and see you on the part 2. See you sa part 2, okay? Which will be all about case number 1 and case number 2.